Hello everybody, this is Mr. Bowman. Today we're going to be looking at how to use the elimination method to solve a system of equations. So, what we're looking at here when we have the elimination method is it's going to be very similar to the substitution method, where our main goal is to get rid of one of our variables. We want to get down to one equation with one single variable. So, how we're going to do that is we are going to eliminate, basically, it's where they get the name from. We're going to add our equations together in such a way that one of our variables drops out. We're going to get a coefficient of 0. Okay. So what we're looking at here in this case is we have 2x and negative 2x. So we're looking for coefficients that match if we can get them. So this is 2 and negative 2, which is considered a match because we're not concerned about the signs yet. But in our end, we want it to be the same number, but one positive and one negative. So when they add together, they add up to 0. And this one already starts that way. Next, we'll look at one that does not start that way and how we can turn it into that situation. So I have 2x and negative 2x, so I can quite literally add these equations together as written. So I'm going to make sure everything is in the right order. So x, y equals constant, almost standard form there, but I don't care if the a is negative in this instance. Excuse me. But I can go ahead and add those like terms together. So I have 2x and negative 2x is 0x. 4y and 5y is 9y. And then 18 and 0 is 18. So now 0 times x is 0. It effectively drops out. So I have my single one equation with one variable. I only have y's. So I'm going to go ahead and solve for that. So I divide both sides by 9, and I get y equals 2. So remember with this, we are looking for an intersection point. So I need an x and a y to get the coordinates of that point. So I have y equals 2, so I'm going to put that in my y slot of my point. And then I need to plug it back in to one of my two original equations in order to get that x value. So it doesn't matter which one you pick. I'm going to go with the first one just because there's no negative sign, so I don't have to worry about dropping a negative by accident. So I have 2x plus 4y equals 18, just bringing that down. Then I'm going to replace my y value with a 2. So 2x plus, instead of 4y, it'll be 4 times 2. So all I have to do here is solve for x because there's no y's anymore. So once again, I had that one equation, one variable. So 2x, 4 times 2 is 8. Subtract 8 from both sides. Divide by 2, divide by 2, x equals 5. So I'm going to come up here, put that in my x spot. My answer for this one is 5, 2. So what do we do then if we have a situation like this, where we don't have coefficients that nicely line up? Okay, I don't have a negative 2 or a negative 4 to cancel out one of these ones. So what we're going to do is we're going to force it into a to fit our system. So what I mean by that is we're going to multiply one or possibly both of our equations by a number so that the resulting system will turn into one of these nice ones where we have, say, 2 and negative 2 or something that's going to add up to 0. So in this one, I can do it in one step as opposed to 2 and changing both of these equations, because if I multiply this one by negative 2, when I distribute the negative 2 in here, I'll have negative 2x and 2x like I did on my last one. You have other options. Say you want to get rid of the y first. You could, say, multiply this top one by everything by 4 and everything in the bottom one by 3, and you would have negative 12y and 12y, and you could add up those and get rid of them. But that will take 2 steps, so I'm going to do this one because it's in 1. But if you don't see that and you use 2, that's perfectly fine as well. So this one I'm just going to bring over because I'm not doing anything to it. This one I'm going to multiply everything by negative 2. So now I can come over and put these together. So I have negative 2x and 2x is 0x again. 6y and 4y is 10y. Negative 10 and 20 is positive 10. And so I'm down to my one equation, one variable. Divide by 10. Y equals 1. So once again, coming over, I need an x and a y. My y is 1. We'll put that in the y slot. Plug that back in. Notice we did change them. If you did everything correctly, these should be just as safe to plug into as here, but in the off chance that you did make a mistake, it's usually sometimes a better idea to go back to the originals. So I'm going to use the second one because that's not something I added stuff to when I wrote around it, so I don't have to worry about accidentally miswriting something. So I have 2x plus 4y equals 20. 2x plus 4 times 1 equals 20. 2x, 4 times 1 is 4. Subtract my 4. Divide by 2, and x equals 8. So my point for this one is 8, 1 for my solution.